All right, welcome to today's explainer. We're going on a truly fascinating journey today. We're going to bridge the gap between the incredibly complex physics of fluid dynamics and the real-world, high-stakes decisions involved in B2B fleet procurement. If you've ever found yourself wondering exactly how modern logistics safely moves everything from aviation fuel to liquid sugar, well, you are absolutely in the right place.
Okay, let's dive into this. It's a super foundational question, right? Why can't you just put liquids in a standard freight box? Why not just use those standard 53-foot dry van trailers we see everywhere on the highway? Well, hauling stable, palletized freight in a dry van is vastly different from transporting volatile bulk liquids. Because when your cargo behaves like a living, moving entity, traditional freight equipment goes right out the window. Yeah, standard freight just fails completely when a payload can slosh around or physically expand as it warms up, or, worst of all, chemically react with its own container. You see, tank trucks aren't just empty containers. They are highly specialized, precision-engineered commercial vehicles. Every single aspect, I'm talking from the specific shape of the tank all the way to the operating pressure, is meticulously engineered. It has to prevent contamination, handle intense internal pressures, manage massive amounts of kinetic energy, and most importantly, keep that heavy chassis stable and safe on the highway. Let's move to and see how this builds across our agenda for today. First, we'll tackle the bulk cargo challenge. Then, categorize the 6 main types of tankers. After that, we'll look at the tricky balance of volume versus cargo weight, dive into materials and fluid dynamics, and finally, wrap up with a B2B procurement guide. So, starting with part 1, the bulk cargo challenge, where physics meets the highway. This is essentially a constant, high-stakes balancing act for fleet operators between strict safety compliance and maximizing that payload. Moving into part 2, 6 types of tankers, categorizing by cargo chemistry. Because you definitely can't use a one-size-fits-all approach here. The specific chemistry of the cargo completely dictates the engineering. And this brilliantly illustrates just how specialized this equipment gets. For fuel and petroleum, we use DOT 406 low-pressure aluminum tanks, specifically to prevent sparks. Industrial chemicals, they require DOT 407 specs with custom fiberglass or rubber linings. Then, think about food-grade sanitary transports. These are essentially rolling clean rooms, complete with clean-in-place systems, so a tiny bit of residue from one load doesn't completely ruin thousands of gallons of the next one. For cryogenic transports, built to MC 338 specs, they literally act as giant thermoses on wheels, using double-walled vacuum insulation just to hold sub-zero liquids. Compressed gas requires MC 331 high-strength cylinders to manage those intense internal pressures. And finally, corrosive haulers dealing with heavy acids prioritize extremely thick coatings and reinforced welds over weight savings, basically to prevent the tank from being eaten alive. Which brings us to part 3, volume versus cargo weight, or what the industry calls the density trap. This is a massive pitfall for buyers. There is this counterintuitive industry secret regarding weighing out versus cubing out. Basically, if you're hauling a really dense, heavy industrial fluid, like liquid fertilizer, for example, you will almost always weigh out. That means you hit the maximum legal axle weight limits for the highway long before you cube out, or actually fill up the physical geometric space of the tank. Think about it. If you buy a massive tank for a really heavy liquid, you're going to be driving around half empty just to stay street legal, and that is just a terrible waste of capital. So operational volume completely dictates your vehicle type. Small capacities under 3,000 gallons are the sweet spot for maneuverable urban straight trucks doing local fuel or water delivery. The mid-range, up to 7,000 gallons, is perfect for regional routes. And everything above that, pushing up toward 11,600 gallons, is purely the domain of massive terminal-to-terminal tractor trailers. Also, it's worth noting that when sizing specialty tanks, like for cryogenics, it's not just about the liquid capacity. Engineers actually have to calculate the vapor space, which is known in the industry as ullage, just to ensure gases have enough room to safely expand as temperatures fluctuate. Okay, section 4, materials and fluid dynamics, focusing on taming the slosh. Let's look at the internal mechanical engineering required to keep these trucks right side up. Now, what's really interesting about this concept of slosh, which is those violent, uncontrolled fluid surges that happen every time a driver hits the brakes or takes a sharp corner, is how we combat it. Engineers install internal metal bulkheads called baffles. These act exactly like breakwaters in the ocean, breaking up and slowing down the fluid's momentum. But here is the wild part. Sanitary laws strictly forbid internal baffles in food-grade tanks because bacteria could hide in the corners and welds.
So milk and liquid food haulers are forced to use completely hollow, smooth-bore tanks. And driving a smoothbore tank requires incredibly highly skilled, specialized training because there is absolutely nothing stopping thousands of pounds of liquid from surging forward the second they hit the brakes. Crazy, right? Let's quickly fire through the engineering triangle for the outer shell, because your material choice directly impacts your vehicle's empty weight and ultimately your ROI. Aluminum alloy is the global standard for fuel. It's super lightweight and naturally prevents sparks. Carbon steel gives you fantastic tensile strength on a budget, making it perfect for heavy-duty water trucks, though it does need special coatings to stop rust. And stainless steel? Well, it's heavy and expensive, but its aggressive resistance to chemicals and oxidation makes it absolutely mandatory for anything food-grade or high purity. Wrapping things up with Part 5, the B2B Procurement Guide, Specifying and Sourcing. Because honestly, a flawless tank design is entirely useless if it's sitting on the wrong chassis. Fleet managers often rely on specialized B2B platforms to evaluate global manufacturing just to nail these exact steps. Step 1, you absolutely have to match the drive type. An Agile 4x2 works great for the city, but you're going to need an 8x4 configuration for rugged off-road mining. Step 2, your chassis engine has to have enough torque to power the PTO, the power takeoff, to run high-capacity discharge pumps without stalling out the whole truck. And step 3, you must verify global compliance, making sure the vehicle meets strict international pressure vessel codes like ADR in Europe or ASME standards. I want to pause here and give you a direct pro tip straight from the procurement experts. Never ever submit a vague request for quotation. If you don't explicitly state your liquid's specific gravity and operating temperature, the engineers literally cannot calculate safe axle loads or proper wall thickness. You also need to specify your required pump flow rates in gallons or liters per minute right up front. If you just ask for a generic 5,000-gallon tank without this critical data, you are actively inviting costly redesigns, blown budgets, and a fundamentally unsafe vehicle. So, the crucial point is, you really have to plan ahead. Custom chemical carriers and complex refuelers take anywhere from 60 to 90 days to build. Compare that to maybe 30 days for a simple water sprinkler. Lead times are heavily dictated by global chassis availability and the intense customization required. But keep in mind, for standard semi-trailer tanks, negotiating a bulk order of 5 or more units can significantly lower your per-unit cost compared to the single-unit minimums you often see with specialized straight trucks. To wrap up today's explainer, I want to leave you with this thought. Next time you're cruising down the highway and you pass one of these massive vehicles, ask yourself, how much extreme engineering, complex fluid dynamics, and global B2B logistics did it take just to safely move that gallon of milk or gasoline? It's really an incredible marriage of physics and supply chain management that keeps our entire world running. Thanks so much for learning with me today, and keep asking those great questions.